Hey Jen, I just thought I'd put this into a recording because the solution for this question for your practice test was quite bad. It only really said the answer. There was no working out. And also during the session, I was getting a bit confused. So yeah, sorry about that. But hopefully this video takes away the confusion. So I think this was the question. Find values for m so that the line y equals mx intersects a line y equals x plus 2 only once. Now, I'll just draw it up, but I want to say that I think when you started looking at the question, you were getting confused from the previous part. Like this is part B, you were getting confused on part A, whereas like y equals 3x or something. This has got nothing to do with that previous part. So even though they've got the same absolute value functions, the two different parts are sort of unrelated. So I don't want you to get confused by that. So this yellow line here is absolute value function. And right here, this is the y equals mx function. So as you can see right now, it has no intersections. But if we change the orientation, say that it's this way, for a different value of m, we have one intersection, which is good. And if we change it like, so it goes like this, we have two intersections, so that's bad. So what we're trying to do is find all the ways that we can have this line have one intersection, all the ways that it can have one intersection, so like this or like this, but we don't want it to have two intersections. So I'll just put up Desmos so we can see it like this. So to start off with, right here, when m is -1, these two lines are parallel, so they have no intersection. So, I mean, this line here and this line here are parallel, so they have no intersection, because the gradient of this is -1, and the gradient of this one's +1. So we want m to actually be less than -1. And if we make this value even more negative, it still has one intersection. So it still has one intersection here, and we can make this so negative, we can make it almost vertical, -1,000, and it has one intersection. So that's good, so that's what we want. So we want m to be able to go to -infinity. So m is greater than -infinity, because we can make that so negative and it will still satisfy our criteria of intersecting once. But as soon as we make m equal to -1, there's no intersection. Or if we make it 0.9, there's two intersections. So we want it to be sort of closer to -infinity than to -1. So that's when our gradient is negative. Now, what about if we have a positive gradient? So if we have a positive gradient of 1, there is no intersection at all. So what we want our gradient to be is actually slightly steeper than that. So we want m to be actually, we want m to be greater than 1. Because we want m to be slightly steeper than that. Now, if we move m to 10 or 1,000, it still has one intersection, so that still satisfies our criteria. So we can make that super high and it will still have just one intersection here. So we can have m is less than +infinity there. So these are kind of two answers for m. Now, there's one last answer, which is when m equals 0. And when m equals 0, the line is flat, and we intersect this absolute value function just once. So that satisfies the criteria as well. So just to be clear, the criteria that we want is for the red line to intersect the green line just once. And these are the ranges for m here that satisfy this. Okay, thank you.